Aashto T255, total evaporable moisture content of aggregate by drying, covers the determination of evaporable moisture in an aggregate sample. This method is sufficiently accurate for common purposes, such as adjusting concrete batch quantities. For this test, you will need a balance with a capacity readable to 0.1% of the sample mass or better. A source of heat, preferably a ventilated, temperature-controlled oven, capable of maintaining a temperature of 230 plus or minus 9 degrees Fahrenheit. Temperature-controlled convection ovens are recommended. Use a container that will not be damaged by the heat and is large enough to hold the entire sample without loss of material. Be sure your sample has been obtained according to Aashto T2 and has been transported and stored in a moisture-proof container. Table 1 lists minimum sample sizes for aggregates of differing nominal maximum sizes. The depth of the sample must not exceed 1/5 of the container's narrowest width. Make certain that the sample mass meets the minimum requirement. Begin by recording the mass of the test sample to the nearest 0.1%. Then dry the sample until further drying will result in less than 0.1% additional loss in mass. If a controlled temperature oven is unavailable, you may use a hot plate, but care must be taken to avoid overheating the sample. If hot plates are used, stir the sample occasionally to evenly distribute the heat. However, once you have recorded the original mass of the test sample, great care must be taken to ensure that no material is lost, since all loss in mass will be calculated as moisture content. T255 allows for quickening of the hot plate drying process by the ignition of anhydrous denatured alcohol. However, due to safety concerns, this process is widely discouraged and will not be covered in this tutorial. Once your sample has dried, allow it to cool just enough to prevent damage to the scale. Then weigh the sample and record the mass to the nearest 0.1%. And calculate the total evaporable moisture content of the sample as follows.
For this simple calculation, we'll call the answer we're looking for P. The original mass of the sample, that is the total sample weight before drying, we'll call W. And the mass of the sample after drying will be D. The formula looks like this. P equals 100 times W minus D divided by D. First, subtract the mass of the dried sample, D, from the mass of the original sample, W, to get the mass of the water that evaporated during the drying process. Then divide that number by the mass of the dried sample, D. Finally, multiply the result by 100, or simply move the decimal 2 places to the right to get the amount of moisture expressed as a percentage of the original dry sample weight. The fact that the result is not expressed as a percentage of the original weight before drying sometimes causes confusion. It is important to remember that you divide the moisture by the dry weight. Many technicians, especially beginners, mistakenly assume that the result of this test is a representation of the percentage of water in a given sample. For example, a 10-pound sample containing 1 pound of water and 9 pounds of aggregate would have a total evaporable moisture content of 10%. This is not the case. The result from that sample would actually be 10 minus 9 equals 1. 1 divided by 9 equals 0.111. Multiplied by 100 equals 11.1% total evaporable moisture. Keeping this in mind will help you remember to divide by the original dry weight. Report your answer to the nearest 0.1%.
For more details on the most recent specifications, consult the latest Aashto publication, which may be ordered by calling 202-624-5800 or online at transportation.org.